and welcome to Meetings in Math. We're here looking at solving special systems of linear equations. Our essential question is, what happens to the solution of a system when the lines are parallel, and what happens when the lines completely overlap, making them the same line? Today you will need your Jaguar Jots on section 5.4, a pen or a pencil. You might find a highlighter helpful, a calculator to keep things moving along quickly, your problem solving skills, your bright ideas, and your determination. So let's get started. In our first case, we're going to look at these two equations, y equals x and y equals x plus 3. And so we want to begin by graphing. So the first thing we want to look at, of course, is what is the slope and what is our y-intercept so that we can graph it. So we'll graph the first one in green. So m is equal to 1, because remember, when there's not anything in front of the x, it is 1. And since there's nothing after it, b is equal to 0. So we're going to start here at 0. And then we're going to go up 1 and over 1. And we're going to continue to do that to make our line. So then let's take our ruler and make our straight line that goes on from there. And there's our line. And now let's do that with the second one. Y equals x plus 3. M is equal to 1. And b is equal to 3. So this time we start at the y-intercept at 3. And again, our slope is 1. So it's up 1, over 1. Get a few of those in place. And draw our lines. So the first thing we need to do is we need to look at their slopes. And what do we notice? We notice that the slopes are equal. Or I hope that you notice that the slopes are equal. And I hope that you remember that that would mean that the slopes, when the slopes are equal, that the lines are parallel. So when the slopes are equal, the lines are parallel. And now we look at the lines. If you look at the lines are not going to intersect. So by the definition of parallel, and also by looking at our picture, we can see that the lines are not going to intersect. And now let's just pull that thread a little bit more. We know that the solution of a system means the point where they intersect. Well, if these are parallel lines and they're never going to intersect, that means that there's never going to be a point where they intersect, which means that parallel lines don't have a solution. And so that is what we were looking for this whole time, which is graph the following lines and determine the solution of the system. In this case, since they're parallel lines, they're not going to have a solution because they never intersect. So the lines will never intersect, so they cannot have a solution. So then what's our answer? Parallel lines have no solution. Remember that those three little dots means therefore. When we see the graph, it's really obvious that there's nothing that's overlapping, nothing that crosses, no solution. So let's look at the second case. Take the line 3x plus y equals 5 and rename it by multiplying the equation by 2. Okay, so we're going to take the line 3x plus y equals 5. And now we're going to give it a new name. It's going to be the same line. We're just going to rename it. So 3x plus y equals 5. And now I'm going to multiply both sides by 2, and I have to do both sides so that it stays equivalent. So 2 times 3x is a 6x, and 2 times y is a 2y, and 5 times 2 is 10. So these are the exact same lines, just with different names. And so if I was to graph them, I would end up in the exact same place. So here we are on Desmos looking at the two lines. The first one that we were given, 3x plus y equals 5, and there it is graphed. The second one we were given was 6x plus 2y equals 10. That was the one where we renamed it by multiplying by 2. And what happens when I graph it is we can see that it's the exact same line. They're in the exact same place. So what would you say about these solutions? Well, we can obviously see that first one right here at 0, 5. And we can see this next one at 1.667. 0. But I can put numbers all along here, and every one of these points is on both lines. And I could do this forever. I could zoom it out as much as I want, And all of those points are on both of these lines. And I could be doing this forever and ever and ever. I could zoom in into these very small numbers as well, or I could zoom out into these very big numbers. And so the only way I could talk about all of those numbers, whether they're very, very small or very, very big, is to say infinitely many. That takes care of all of those numbers. And so our answer for this would be when lines are the same, they are infinitely many. And remember, they can be the same without looking the same. So 3x plus y equals 5 is the same as 6x plus 2y equals 10. Those are the same lines. You might also hear when the lines are the same, they have infinite solutions. Both of those are correct answers. So how in the world do you figure out which one's which? Well, it gets down to what does your answer look like? And we'll talk about that in just a second. But those are the two big ideas that we're going to look at. So let's look at this activity. You invest $500 for equipment to make dog backpacks. Each backpack is going to cost you $15 for materials. You will see sell each backpack for $15. When will you break even? Okay, so in other words, are you ever going to make enough money to make up your $500? So X is going to be your backpacks. C is your cost to make, and R is your revenue. So before you spend any money at all, or before you make any backpack at all, you have to spend $500 just to get ready to go. And you have not made a single dime. But when you sell your first backpack, you have to spend another $15 just to put $15 of material into there. So you have to spend your $500 plus 15 more, but you do get to make some money. You're going to make $15. And then we're going to continue on that pattern. So your second one, you have to put $15 more into that backpack. So that would be $530. But you made $15, so you made $30. So this is going up by 15, while this is going up by 15. Sounds good. So this here, you had to spend $15 more, and you earned $15. The question becomes, is this here growing fast enough that it will ever overtake this? Well, at 10 backpacks, 15 times 10, that's how much more money you had to spend. That would be $150 more. So you spent $650, but you made money. You made $150. You're still in the whole $500. Each time you're in the whole $500. It doesn't look like you're ever going to make up your $500 of your initial cost. Why is that? Well, think about the fact that what's really going on with X every single time. Well, your cost was that initial $500 plus the 15 for every backpack. Your revenue is 15 for every backpack. Remember y equals mx plus b? Your slope, in both of these, your slope is 15. So are you ever going to make back your money? No. You need to start charging more for your backpacks. Your charge for your backpacks needs to be more than what it cost you to make it. So the cost to make the backpack and the revenue for selling the backpack, they're the same. So they're never going to be able to make back that $500 so that they can break even. So now we're just going to look at practice problems. We're just going to try to figure out, are these lines going to have no solution or infinite solutions? So when I look at this first one, I see y equals and y equals. And what instantly comes to mind is this idea of I have a card, and on one side it says y, and on the other side it says negative 2x plus 5. The other card says y, and on the other side it says negative 2x plus 1. So I am going to set them equal to each other. On this card, every time I see a y, I'm going to put in negative 2x plus 1. So instead of a y, negative 2x plus 5, instead of this y, I'm going to put in negative 2x plus 1. So I slid those into place. They are equal to each other. Another way that I can remember that I'm doing it was I said y equals y, right? This y is equal to this y. And now I substituted in those cards. I flipped them over. So now here are my variables. So I'm going to move this one over here. So I'm going to add 2x to both sides. So that is 0. So now I have 1 equals, and that is 0, and that is 5. So this is where the magic happens. I have this answer, 1 equals 5. And I ask myself, is that true or is that false? And that is absolutely false. And since that is false, that means it can't happen. Therefore, I have no solution. Just like before, if I was ever solving an equation and I ever got something weird happen where all my variables went away and it was a no solution, it's still a no solution. Why is this a no solution? It is because they have the same slope but a different y-intercept, so the lines are parallel. Okay, so if we kind of looked at that again, if we take this one, m is equal to -2, but b is equal to 5. And if we took this one, m is equal to -2, but b is equal to 1, you can see the slopes are the same, but the y-intercepts are different. But you don't have to show that part. All you have to show is this algebra. If you want to show this other part, I guess you can, but the algebra is the real fast way to get to the answer. So let's look at this next one. When I look at this next one, what I see is elimination is really easy to do, only because I notice I'm really close to having additive inverses. I am looking at my 2x and my -12. So on this one, if you take this 6 and you multiply it by 2x, you get 12x, and then 6 times -4 is -24y, and then 6 times 10 is 60. And then this should be -12x plus a 24y is equal to -60. So 12x minus 12x is 0. And -24y plus 24y is also 0. And then 60 minus 60 is 0. So you end up with this 0 minus 0. And that is true. And so because the statement is true, that means I could put anything that I want in for x and y. And so our answer is infinitely many solutions, or infinite solutions. And so we end up with this really nice way to show it. You could have also done this by substitution and solved out one of your equations for x or y and done something more similar like A. Let's look at C. Let's go ahead and take C and do it by substitution with some extra steps. Let's take our first equation and solve it out for y. So 2x plus y is equal to 5. So I'm going to subtract both sides by -2x. So now I have y equals -2x plus 5. Yes, it's a few more steps, but it's okay to take a few more steps to do this. So now I'm going to take this and I'm going to put it into that equation. So 4x plus 2y equals 0. But now instead of y, which is here, I'm going to put in that. -2x plus 5. So 4x plus a -4x plus 10 equals 0. So 4x minus 4x is 0. So 0 plus 10 equals 0. So 10 equals 0. So again, here we're looking at a false statement. And since it's false, it's no solution. Notice on all of these, I'm not going to find a second answer because I don't have any variables to substitute in to find that second answer. We're canceling out our variables on all of these and either having to make a decision if it's true, it is infinite solutions, and if it's false, it is no solution. So let's look at D. And let's go ahead and do this one again by substitution. I would probably, actually let's do this one by elimination. This is a very nice one to do by elimination because we already have a very nice additive inverse here with a positive y and a negative y. That there becomes 0. And I am left with a 2x is equal to 3 plus 3 is 6. So now I'm going to divide both sides by 2 and x is equal to 3. So this here is not a special solution. This here is an actual answer that I'm going to be able to find on a graph because I have a value. So now I'm going to take my x equals 3 and put it into either one of those. I'm going to use the top one because it's all positives. So now instead of x, I'm going to use 3. So I'm going to subtract 3 and y equals 0. Now, just because I got y equals 0, that doesn't mean it's a no solution or an infinite solution. This means that y is actually equal to 0. So my answer is 3, 0. So what I would like you to do today is I would actually like you to write down when it is that you have no solution and what kind of thing you're looking for when you have infinitely many. And what I mean by that is, what are you getting for answers here? So what are you looking for when you have no solution? What are you looking for when you have infinitely many solutions? And what are you looking for when you have one solution? And what I mean by one solution is this. And then I want you to make sure you tune in for our next lesson, because we are going to summarize those all nicely into one type of answer. All right. Thank you very much for showing up. And I can't wait until our next lesson where we can summarize this all together very nicely and neatly and put a nice little bow on it. Remember to be nice to each other, because we could all use some extra kindness in our lives. Bye for now.